Okay, so at this time, we'll be looking at resistance or resistors in series and in parallel. We're still under the topic current electricity, but now we're looking at resistors in series and parallel. Now, there are two main ways that we can arrange our resistance, either in series or in parallel. So what we're going to do now is look first at resistors in series, when they're connected in series. So let's look at that. With notes and the aid of a diagram, we have resistors All right, so it says when resistors are connected in series, they are connected end to end. Now, last time we looked at this symbol for a resistor. So this is one way you can draw the circuit symbol for a resistor also. A resistor may be drawn this way. So three spikes, three troughs. So three crests, three troughs that may be used to represent a resistor. Now, when they are connected in series, they are connected end to end. So one end is connected to the other end for another one. So I'm going to join two resistors together. So this is one already. And I'm going to use the same symbol to represent another resistor. So now they are connected end to end. So they are connected in series because one end is connected to the other end of another resistor. Now, if I should draw a circuit to represent this, the circuit would look something like this one here. Here I have my battery. Right? This represents one resistor. This represents another resistor. And depending on the amount of resistors that you have in your circuit, you could go on to even a million. That would not be practical right now. Down here I have my voltage source. I can put V, right? The longer end represents my positive terminal of my battery. The shorter end represents a negative terminal. Now we see that current flows from positive terminal all around the circuit, from down here back to the negative terminal. Now we have three resistors. What we're going to do is we're going to label each of them. Because we have three, we're going to give each of them a number. So this first one, I'm going to call it R1. The second one, I'm going to call it R2. This is the third one, I'm going to call it R3. Now, in this topic, you're going to learn to calculate the total resistance in a circuit. So if you remember from last time, these can all have values, different resistances, which measure how much they hinder the flow of current or impede the flow of current. So RT, R subscript T, will represent the total resistance in this circuit. So total resistance. total, total resistance. Now, if RT represents total resistance, the formula then would be RT, the total resistance in a series setup, is equal to R1, that's the first resistor, plus R2, that's my second resistor, plus R3, that is my third resistor, plus dot. We can go on and on. It's just based on the amount of resistors that you have. Now, this is pretty straightforward. Why is it pretty straightforward? So that is because we're just adding numbers. It's just general arithmetic. We're just adding many times whole numbers or just, yeah, integers in general, regular. Let us now do a question. We need to do an activity to see really how manageable this is. I'm going to use the same diagram. I'm going to put some values of resistance and voltage. I'm going to let my formula stay right here so you can use it as reference. At any point, you can pause the video, write what you need to write, and then play, resume. All right, so here we have a 6 volts battery. It's called 6 volts. And this resistor has a resistance of 2 ohms. This one has a resistance of 4 ohms. And let's make this one 10 ohms. Now, the first thing I need to do is write my formula down. I look at my circuit and I wonder, what type of setup is this? I see the resistors are connected end to end in a single loop. So I realize that, oh, they are in series. So I go ahead and I write my formula down for resistance in series. R subscript T, total resistance, is equal to R1 plus R2 plus R3. And why do I stop at R3? Because I only have 3 resistors. If I had 4, I would have plus R4. If I had only 2, I would have plus R1 plus R2 and would stop. So let's put the values in. This was just a label to represent my first resistor. So what's the resistance of my first resistor? It's 2 ohms. So I put 2 ohms there. Plus, what's this here? R2 is 4 ohms. But plus 4 ohms. And R3 is all of 10 ohms plus 10 ohms. And let's add it. 2 plus 4 plus 10. That gives us, let me see, 2 plus 4 is 6. 6 plus 10 is 16 ohms. And that is my total resistance in my circuit. Just that. That's all you need to do. With that said, you can pause the video to take this down. We're moving on to resistance in current. Right about now. So resistors connected in parallel are put in different branches in our circuit. This means that they can receive different current also. This is just an extra piece that you will need sometime in the future. Different current values. Now, if a resistor is connected in series, all those resistors, they receive the same current. But when connected in parallel, they can receive different current values. Let us look at them connected in parallel. So let me put my voltage source right here. This is my voltage source. Just drawing some different branches in my circuit. So I have 3 branches. 1, 2, 3 branches. And I hope that is not too low. I'm going to draw it a bit higher. So 3 branches in this circuit. So all right, this is a bit small. Yes, you can see. Now I'm going to put a resistor right here. I'm going to put another resistor right here. I'm going to put one in this branch down here. Positive terminal, negative terminal, 6 volts, 2 ohms. I'm going to use the same values as our previous question. 4 ohms, 10 ohms. Now, what I want you to realize now is that we have 3 different branches in our circuit. Now, the current travels from the positive terminal around to the negative terminal. Let's look at the current flow now. So the current will travel from here, conventional current. When it reaches the junction here, some of the current will go through the first branch, while the rest will travel downwards. Some will go through the second branch, and the rest will go around to the third branch, the third resistor. Now, as they reach the negative side of my circuit, the current will combine at each junction. So here, this current will combine until the total current enters the negative terminal. Now it looks crowded. What I'll do is redraw it now, taking out some of the arrows. So 1, 2, 3. Right? This is my 2 ohm resistor. 1, 2, 3. This is my 4 ohm resistor. And down here, I believe I have 10 ohms. 10 ohms. Good. Now, they are in different branches, and sometimes a way to remember this is that they are parallel to each other. They are running in the same direction, but they are not touching. So they are arranging parallel. But how I like to remember it is that they are in different branches altogether, different branches in the circuit. That means the current that they get can be different. Now, let's move over here to the formula. Now, this one is one you'll have to practice, maybe memorize, but more so if you practice, you won't have to memorize. It will be right there in your retrievable memory. So, RT again will be our total resistance in our circuit. So, RT is total resistance. Now, this is the formula. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, this is my R resistor 1, this is my resistor 2, and this is my resistor 3. So I can put R1 right here, R2, and this is R3. So you realize the total resistance could not be found simply by just adding 1 over R1 plus 1 over R2, because that is just giving us 1 over the total resistance. When we're done, we need to find what RT is, because this is giving us what 1 over RT is, but we want RT. Might be saying, sir, how are we going to handle that? Let's look, let's see. We're going to use this same diagram with the same values to find the total resistance in that circuit right here. So let's go ahead and let us write our formula first. Formula first. Always 1 over R1 plus 1 over R2 plus 1 over R3. We have 3 resistors. If we had 4, we would have plus 1 over R4. And we could continue just based on the amount of resistors that we have. Now, let's write the values in. 1 over R1. What's the value for R1? R1 is 2 ohms. 1 over R2. R2 is 4, so that's 1 over 4. 1 over R3. R3 is 10, so that's 1 over 10. Now, since we are adding fractions, we need to find the... I'm going to erase this diagram right now, so you need to draw it or take a screenshot or something, and it's gone. We need to find an LCM, or lowest common multiple. It would help to find the LCM because it can make your calculations a lot simpler. So what would be the LCM here? Of 2, 4, 10, I say it's 20. So let's go. 20. 2 into 20 goes 10 times 10 ones. 10. 4 into 20 goes 5 times 5 ones. 5. 10 into 20 goes 2 times 2 ones. 2. So here we get 17 over 20. 1 over RT is equal to 17 over 20. So 1 over our total is equal to 17 over 20. And this is where a lot of persons sometimes go wrong or they lose marks because they leave it right there. Now, what I would suggest you do when you reach right here, you immediately try to find what RT is. So 1 over RT is 17 over 20. All we need to do is reciprocate. So 1 over RT is the reciprocal of RT. That means if you want to find RT and you have 1 over RT, all you need to do is flip it around. So I flip around the left side, I need to flip the right side around. So let's reciprocate. So RT over 1, therefore, is equal to 20 over 17. And let's just drop that in our calculator. That's going to give us something like, yeah, let's drop that in our calculator. All right, so we have 20 divided by 17. And we get 1.18. So I just rounded it off to 2 decimal places. 1.18 amperes. And that's all. So first, when they were connected in series, we got 17 ohms. Now we got 1.18 ohms. So you realize that when the resistors are in parallel, the total resistance is much smaller. It is smaller than the individual resistances. So 1.18 is smaller than any of these right here. All of them. Now this is the formula that you have to use to find total resistance. Let's do another question. All right, here we have a question on the handout. I'll let my formulas here right there, and I'll draw the diagram over here. The diagram looks something like this. Should have looked. It has two branches. That means it has two branches, it has two resistors. As I said, sometimes you have two branches, two resistors, sometimes you have more. Positive terminal, negative. We know that the current flows from positive terminal around to the negative. Now the value for this one is 4 ohms. So this is our R1, this is going to be our R1. Let's make this R2. This is 2 ohms. Now the formula states that 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and we could continue. The first thing we need to identify is the type of circuit, the type of connection that we have with our resistors, and we realize already that the resistors are connected in parallel. So we use our formula over here. Now the next thing we need to consider is the amount of resistors that we have. We have only 2. Therefore, we can modify this formula to only have 2 resistors. So 1 over RT is equal to 1 over R1 plus 2. Now, the next step is to plug our values in. R1 is 4, so it's 1 over 4. R2 is 6, so it's 1 over 6. What can we use as the LCM? I say 12. 4 into 12 goes 3 times. 3 ones, 3. Plus 6 into 12 goes 2 times. 2 ones, 2. And we get 5 over 12. What is equal to 5 over 12? 1 over RT. So we still need to find what RT is. If 1 over RT is 5 over 12, let's write that. So continuing, if 1 over RT, we just calculated that to be 5 over 12. It only means that RT over 1 must be equal to 12 over 5. And this is what we want. So you always reciprocate when you reach right here. Right here. 5 over 12 will give us something like 2.4 ohms. And that's all you need to know to pass your exam.